All right.
Okay, so welcome to FBD Radio. So this time I'm Chris, and it is a podcast to let every more people to know what is factory automation, what is the news of our factory automation that have new technology, new device or something. So we make so many collaborations with so many great manufacturer in overseas in Japan. So this time I'm very interesting and I very appreciate that I can invite a very great guys that come from OpenPLC. It's Damigo-san. Nice to meet you, Damigo-san. Hello.
Thank you. Nice meeting you virtually, Chris. It's a pleasure to be here and talk a little bit
Okay.
about OpenPLC.
Oh,
Yeah.
thank you. Okay, so before that, Damigo-san, could you introduce yourself? Who are you? I think more of a Japanese listener. It's very interesting that what is this guy? Something like this.
All right. All right. So yeah, on the Western version, my name is Thiago Alves. It's a bit more complicated for Japanese listeners with the Thiago sound, but I am, electrical engineer.
Mm-hmm.
And I worked in various industries, and back in about 2013, 14 is when I started this project called OpenPLC,
Okay.
which is an open source PLC implementation.
Okay.
And over the years, it kind of grew a lot and became very popular. Probably the most popular open source PLC in the world. And we've been creating a community around it. So it's been really fun in the journey of maintaining and creating it.
Okay, so thanks. And before we step into bit deep in the OpenPLC, that before I would like to have a deep talk with you about you joined a very interesting event on 2018, right?
That's correct. Yeah.
And
Yeah. That was DEF CON. Yeah.
DevCon, I forgot, I think I watched your DevCon event 2 or 3 times for your YouTube video. It's a very great video that to show how to hack a PLC. But actually, you told me tell us a little bit more why you try to do this crazy thing to try to hack a PLC or yeah.
Yeah. This is I think it needs a little bit background story on that. So this could be a long answer. But back in, as I said, in 2014, I was like an undergrad student, finishing my college degree on electrical engineering in Brazil. So I was born in Brazil.
Okay.
And that, I was, close to finishing that degree. I had an internship on a factory automation. It was they were manufacturing car parts and things like that. And I was really excited at the time, as a kid, going to the factory floor and dealing with robots and things like that. And then as an intern, I got into this project where we had to automate a crash test. So they did like a crash test, and then it was very manual at the time when we had to start everything by hand, and it was insecure, and couldn't collect data correctly. So in the end, we thought we needed a PLC to automate the whole thing, obviously, and that was pretty much my first contact with PLC in the factory floor. But as an intern, you don't have a lot of budget, right? So I couldn't get anything approved, and I had to find spare parts and things like that. It's like, no, wait a second. I know electronics. I'm an electrical engineering student, and you know how students think big of that. At the university, they have no limitations, although they have a lot of limitations. They don't think like that. And that was me. I didn't know exactly what a PLC was. And probably for that reason, I thought I could replicate it very easily. Right? So now I'll build my own. So my ingenuity led me to create something that over the years was actually amazing. So back then, that was in 2012, 2013 around. I created like a prototype using electronic boards that I designed that kind of did the job of a PLC.
Okay.
And it was very successful within that company. You know, it got attention of even the president of the company. It was really nice. I did a presentation about it. It was really cool. And then that kind of pushed me forward and saying, hey, let me publish this thing, make it open source and let everybody benefit from it, because it was cheap. And then I created this OpenPLC project thing. Created a website and put the designs online and started looking for things to make it better. And for my thesis, you know, graduation on the electrical engineering degree, I created a final prototype, and I used some other open source tools, and both in software and some in hardware, to design it. And there was back then an editor called LD Micro. It's still around today, and it could compile code directly to microcontrollers. So from a ladder logic diagram. So I used that. I kind of added a little bit of extra features to it, so it could connect directly to my own baked version of a PLC, and it looked really cool. We replaced an elevator prototype they had at the university just for learning. It was running on a Siemens PLC, and we replicated the ladder logic into my own thing and replaced the PLC, and it worked the same way. So it was really cool. In the end, we published a paper about OpenPLC and open source automation, which back then, was not very widespread. There were other PLC initiatives, open source PLC initiatives, but they never grew in popularity or usage. So it was hard to reach. There were incomplete projects, like you need to fiddle around with a lot of things, and it's not plug and play. You could grab something online and use it. So my task was more like trying to do something that people could really use, and not only for nerds and people that knew how to deal with computers deeply, and could be just the consumer that wants something open source. And that's what I focused on. I published this paper in a congress in California about OpenPLC and how it could help spread automation and around the world, especially in developing countries that don't have access to automation because of its cost. And it got a lot of interest from the academia, which led me to a PhD here in the United States, which was really cool. So in 2015, I got 3 invitations from 3 different universities here in the US to do a PhD around PLC research. And I picked one that was really interesting. I got an excellent advisor, Dr. Thomas Morris. He is the best, a great friend and a great advisor. He taught me a lot about, not only engineering, but a lot of what I am today, I owe to him in my first steps. So he is still is at the University of Alabama. They have this program on cybersecurity, and his approach was like, hey, you've created this OpenPLC thing, which is an open source PLC. We are here researching about vulnerabilities on PLCs and critical infrastructure, and we don't have a PLC with a source code available for us to fiddle with. So your project, your design should be very interesting to add to our research, right? And that's how I got into cybersecurity. I joined the PhD program in 2015, and University of Alabama in Huntsville is in a very strategic place in the United States. It's close to the Redstone Arsenal, which is like a military base where they do a lot of research around cybersecurity and some other security related things. So the security aspect of the whole town, the whole city, is very strong, which was put me into this path of looking about the cybersecurity of PLCs. Right.
Okay, that's because I also very interesting that when I watched your video that these guys come from cybersecurity. This I have so many question marks that why you because I don't know in the US or in something in Japan there's I think it's still now there's no a very big connection between cybersecurity and the factory automation. We know that cybersecurity is a very big problem also in our field, but there's not a very expert like you that have the background with factory automations, where electronic can go inside the part of a cybersecurity. And I think that's also that why you can make the OpenPLC now the new version, your architecture that we like this because you have the background of the factory automations to know actually what they need and what they don't need.
Yeah. That is interesting because most of the cybersecurity professionals on we call it OT, right? The operational technology, they come usually from computer science or computer engineering degree, and migrate to a little bit of electrical engineering with PLCs. But they usually have all that background on cybersecurity, protocols, network communication, firewalls, all of that stuff. And it's hard to apply those principles in their mind to what actually happens in the field, right? What happens with PLCs. And I did I approached cybersecurity in reverse. I actually am an electrical engineering. I came from the PLC world and I got a degree in computer engineering with cybersecurity emphasis. So I did that in reverse. So essentially I'm learning cybersecurity principles on my PhD to apply to PLCs, right? That's what I did from 2015 to 2019. That's when I graduated on my PhD. So that was very interesting because my vision about security was very different than the cybersecurity professionals that were trying to apply those concepts to PLCs. And because I was building OpenPLC, and back then, I mean, I was a very fresh, new engineer. So OpenPLC had this evolving paradigm where the code started really bad and started improving a little bit, and I was just adding things here and there as I was doing the research. So while I was doing that, my approach was not to make a secure PLC. That was some people mistakenly think that that was what OpenPLC was about. No, OpenPLC was about something to replicate the current PLCs exactly as much as possible. And then based on that, add security experiments to it. It's like, will this break any PLC? Will this cause harm to critical infrastructure? So that is, the kind of research that I was doing. And this is what led me to DEF CON, which is the thing you were talking about, the presentation I did. So a little bit background on DEF CON. This is a conference that happens in Las Vegas. It's one of the biggest hacking conferences in the world, if not the biggest. And while I was, as a computer engineering cybersecurity student on my PhD, I watched a lot of DEF CON videos. People going there and presenting crazy things, hacking, CPUs and, doing stack overflows and buffer overflows and all of that craziness, which is really cool, like hacking printers and hardware and things like that. So I got really interested in going there as well and say, well, there is a space to present some PLC hacking as well. And when I was doing my research, one of the things that I was trying to do, as I said, OpenPLC was there trying to mimic other PLCs, other devices. And I was comparing some exploits that I was trying to run against OpenPLC and against other manufacturers. It's been a while. I'm trying to bring all of that from memory. So back then in our lab we had like an Allen Bradley Micrologics 1200 series, if I'm not mistaken, and we also had a Schneider M221 PLC. They all run Modbus, right? And OpenPLC also running Modbus is a network protocol to communicate with other devices. And obviously, if you're attacking a PLC, you go from the network perspective, right? You are in the network, you start sending packages to devices, and you see how they scream, right? And again, the purpose of that research was not to cause harm, but it's actually the opposite, is to understand how these devices can be vulnerable and then propose mitigations and work with vendors to apply changes to their architecture so that other bad actors could not do the same. Like if I, as a researcher, can do harm to a device like that, it means that other people, that bad actors could do the same.
Yeah.
Right?
Yeah, because before I watched a video couple times and they talk about the Modbus, and they talk about the attack patterns of what the attacker try to attack the PLC or even any microboard. They have 4 patterns. They have interruptions, they have injection, they have modification, and I forgot the other one. They have to just listen the package. And
yes,
you like injection, right? You like to...
Yeah. Injection is the best of all because you can literally put something in PLC's memory. I think the main problem with all of that is Modbus was designed in 1978.
Yeah, serious,
something like that.
Serious communication base, right? You told me.
Yeah. So this is something that predates TCP/IP internet by several years, decades, right? And so Modbus was not designed to live on a network like ours today. And that's the main problem. It was not designed with security in mind at all, because back then devices were just wired together and that's it. That's the network you have. It's a physical network wired together. And it works great like that. You have, determinism, the serial network is going there. You know exactly, the timing of everything. So it works great. But then when it was upgraded to the TCP variant, things started to go crazy because now you have PLCs connected to TCP/IP networks that are meant for totally different things. And Modbus is essentially a memory mapped thing where you can read and write to registers are mapped to PLC memory. So you can imagine what you can do with that. You have free access to a device's memory with no login, no authentication, no encryption, no nothing. So that's the problem. It's like there's no way to fix this. People have tried. There's no way to fix this. This is flawed by design. The only fix is redoing, change the protocol. But then if you change Modbus, you stop talking to Modbus things. So there's no way to fix this. The way to have a secure Modbus is not using Modbus. And again, I'm not against Modbus. I love it. It's just for the security practices of it, either you keep it in a very isolated network or you just don't use it because it is insecure by default. So that was what I was doing. I was playing with Modbus and trying to do some injections, which means you're basically scanning a device and figuring out the register map and adding random things to the registers and see what happens, right? There is this technique called fuzzing. It's essentially where you inject random pieces of data into registers, or you play with malformed Modbus messages. This is fuzzing. It's kind of like doing that randomly, creating messages and see what breaks. And during that fuzzing process, of course, I found a bunch of things that broke on OpenPLC and I tried to fix them. But it was interesting that one of the packages were causing a buffer overflow on the MicroLogix PLC. And this was really bad. As I said, this is like memory mapped stuff. So it was writing to a segment of memory that, well, I don't remember the details with the vendor, but perhaps included, the operating system or something critical. And what happened is after you run you send this packet over the network and the PLC receives it, it dies.
Yeah.
That's it.
Yeah, because I see your
So
demo.
it stops working. Yeah.
The Logway PLC is crash, and even you told at the video you told us that even to return the power, it will not resume back.
It doesn't come back. You have to reflash it. Yes. So it was very critical because it was a single, if I'm not mistaken, I think it was a single packet or maybe a sequence of a few packets. I mean, it's been 10 years, but almost 10 years. But in the end, it was just this little thing that would crash a Micrologix PLC. And imagine that on a plant, with dozens, hundreds, thousands of Micrologix PLCs, you could kill all of them.
Yeah.
So I reached out to Alan Bradley. We published a CVE, which is for cybersecurity terms, it's kind of like a document that describes what is wrong for the general public. This document is only published after the vendor has patched the vulnerability, so that it's not widespread, on the wild while the device is vulnerable. Right, so there is a solution to this, and then the document is published. Either that, or the vendor decides not to apply any fixes, and then it stays the way it is.
Okay.
So Alan Bradley was very cooperative. Rocco, right? Alan Bradley, Rocco, and they provided a fix shortly after with a firmware update that prevented the buffer overflow, and everything was good. My attack would not work on the device anymore, and so. Recommendation is update your firmware and then you're good, right? So that was it. But meanwhile, I was also trying, some things against the Schneider M221 PLC.
It's a crazy. Yeah, I see movie. Yeah, I see your movie.
Yeah,
very crazy thing on that.
Yeah, that was interesting because the Schneider PLC uses Modbus for everything.
Yeah.
Right? Schneider bought Modicon, and Modicon is the one that invented Modbus. So this was a very interesting research because Modbus is not only used for inter-device communication, like usually you have two devices reading registers of each other. Modbus was used for everything. Right?
Yeah.
Even logging in, submitting a project file, everything. And they created this sub-protocol that was running inside a Modbus command, right? So Modbus, if you go to the spec, there are some reserved function codes. There are vendor dependent. So these reserved function codes, they are Modbus function codes, but they are not defined on the standard. So each vendor can use that space to create custom codes or custom functions to do whatever they want. So Schneider used one of those to add a whole protocol on top of that. I forgot what it was called. But anyway.
It's 5A. I don't remember. Hack code is called 5A. And
that is the hexadecimal code for that protocol.
Yeah, and you told me that the protocol inside have the Modbus protocol, and at that time they use that protocol. You create a Unity protocol. Unity
Protocol. That's right. That's it. And the Unity protocol is like adding more functionality to the base Modbus protocol. Like that is the payload of the Modbus protocol. And I started reverse engineering that protocol with the help of a friend online that was trying to do the same thing. Crazy people. And there's obviously no documentation about how Unity works. But there are the DLLs on Schneider, what was it called? So Machine Basic or Echo Structure, I don't remember. Yeah. So the DLLs that talk to the PLC, they have all the symbols in there. So it was really easy to go and, reverse engineer the DLLs files and get, how they work. And from that, we figure out how the protocol inside the PLC work. Well, long story short, I found out that there's this command that goes on during login that essentially reads memory segments right, is a command to read memory. And that is entire memory. It's not restricted to something. It can read anything. So like, oh, cool. So what can I do with this? Well, I can use it to read the header of the PLC project file, which, by the way, contains a password protected. If you have a password protected project, the password is there in clear text. Right, so the password is stored in clear text on the PLC. Very, very bad idea. But then in the end, I crafted this little program in C# that would send this command over to a Schneider M221 and return that header. And within the header, you can clearly see, if there is a password protecting the project, you see the password. So if you're using, you're connecting to a PLC and it asks you for password, like that project is password protected, you don't know the password, well, just read the memory back and get the password, and then it can type it in. Worked every time. Yeah. Right.
You also told this story to Schneider Electrical, is that correct?
Yes. As we did with Alan Bradley, Rockwell, we reached out to Schneider, mentioned the problem, and their response was basically like, this is how the system is designed, there's nothing we can do about it. So we published it anyway.
You told me in the video the answer is disable it. If you don't want to,
yes,
you have to make security, just disable it. Hey, come on, this not work.
Yeah, there's no workaround. I mean, either you protect your network very tightly, keep an air-gapped network so nothing can scan or do, or don't trust the password protection mechanism because it's flawed. I don't know, like, it's been many years. I haven't been in touch with Schneider, so I don't know how the system is now, if it's still vulnerable to this or not. I really don't know. I haven't tested it in many, many years. But back then, that was their response, right? There's nothing we can do about it. That's how the system was designed, and that's how it works. So essentially, there's no protection.
Please disable it.
Yeah. So yeah, that was the story behind all my cybersecurity research and all of that.
Very nice. And you also mentioned that the PLC that we are using even in today is expensive, and if using so many technology is more than 40 years before, and it's a closed source. Is the relationship that why you create your OpenPLC V3 or even to integrate the V4? Is there any connections on that?
Yeah, definitely. So what happened is, obviously, when I started OpenPLC, it was because I realized that the whole PLC industry is very expensive, is very vendor locked in. So vendors kind of put high prices, and they all agree in having expensive devices and software, and mostly not only the hardware, right? Today you actually can find reasonably priced PLCs, even from big manufacturers like Siemens. Think of Siemens S7. What was that?
1,200 something.
Yeah, 1,200. That is the most popular one. You can get it for a couple $100, which is fair, right? I think the worst part is actually on the software license. How much it costs to get a seat, a license to program the device. And all the vendors, most of them have, paid IDEs, which you don't see on the IT world. Like, you're going to program in Python. How much does it cost? Nothing.
Nothing. You can just download VS Code. Even you can use a notepad to program it, right?
Yeah. Same goes for C# or C++ or any, name the language. That's why there's a huge adoption of these IT world languages, programming languages, and very low adoption of industrial languages, because kids cannot get into PLC programming because that's expensive.
Yeah, sure. That's
they can't simply download a software and practice. It's like, let me try to write this little thing. Arduino came up with their environment, which is really nice. And kids can program in C++ using Arduino IDE for, with a very low budget. So there's no equivalent thing on the PLC world, right? And that was my intention, to create kind of like an Arduino version of a PLC, right? Something that is accessible and everybody could play with. Obviously, I sidetracked to cybersecurity on my PhD. That's what I did, and I fell in love with cybersecurity. Learned a lot of concepts there. And again, OpenPLC was essentially a test bed. It was my tool. It was not a project intended anymore for people to use, but it was my tool for research. And that's why there are so many research papers published around that time, and even today, using OpenPLC for research and how it can work with, security test beds and things like that. Now, then back in 2023, or around that time, I was working on something totally different, not related to automation anymore. I was completely into cybersecurity, still passionate about automation, but working with other companies doing cybersecurity products. And that's this shift on my career when I realized that OpenPLC was being used all around the world, not only as a cybersecurity research tool, but actually as a PLC. People were putting that on, home automation, even factory floor, and it's like, man, this is nuts. And then I have never tracked usage. I just let it be. And I was always in the forum answering questions when people asked questions. And when they asked for new features, I would just quickly, add them. So there was a lot of hot glue and a lot of, duct tape on OpenPLC because of that. Because, I was not putting my main attention into it. I was maintaining as a side project over all these years. And then back in 2023, I realized that the project was actually bringing awareness to a lot of people. For the first time, I put a tracker on the website just to check how many people were visiting the website. And I was astonished when I realized that 70,000 people were visiting the website per month. Per month. And I was not doing anything about it. And I was like, man, this is wrong. So, as I said, back then, OpenPLC relied on a lot of other open source tools and solutions. Arduino CLI to compile for Arduino targets, Baramis as the IDE, and a lot of other components that I just hot glued together to create like a easy to use, affordable solution. And then I said, no, something needs to be done about this. I talked to a few people and decided to start a company. So that's when Autonomy was born in 2023, based on that vision that, OpenPLC can be more than just a PLC test bed, and people are using it for more than that. And obviously, the design of it was not ideal, because it was built for research, not for industrial usage, right? And then I said, well, let's do something about it. I talked to a couple of companies, Arduino included. Fabio, he's now in the board of Qualcomm since Qualcomm bought Arduino. He's a great friend and helped me a lot over that time when OpenPLC Autonomy was being formed. And he was our first sponsor to establish Autonomy. So I'm very grateful for all the work that he did in helping me and Arduino in general, because without them, this would have never started, right? And over the years, other companies have joined sponsoring the project as well. And with their help, I was able to hire some developers and started this project about rebuilding OpenPLC from scratch. So tossed out everything we had. And, over the past, how many years, 8, 9 years, I collected a lot of knowledge about PLCs in general, how people would use OpenPLC, what the industry looks like. So I had a very good idea how this new OpenPLC had to be, right? So I created what is now called OpenPLC V4, the fourth version. Yeah, and it's a total rewrite, right? It's obviously a work in progress as we started replacing components. We're still using the old compiler. It's a MAT-IC, which powers some other PLC open source solutions out there as well. And obviously for compatibility reasons, we didn't want to break support for what was running before. But we have also built a new compiler to replace it called Struck, which is really nice. And the compiler replacement is happening over the next few months. So we started this process of rebuilding the whole thing. So the runtime was rebuilt from scratch. The IDE, the editor, was rebuilt from scratch. And the main vision is we need to build it using web standards. Going back to the Modbus story where, it was built in an era where internet was not a thing. The same goes for PLC manufacturers and software. You probably notice that, using any PLC IDE, it feels like you're in 1998.
Yes,
right?
I know this
It
feeling.
is old, it's sluggish, it fails a lot, it crashes, it's random stuff. And I'm like, well, we have evolved significantly in technology and language, programming languages. So we need to use what is the most modern out there to build this. So we're using React and Electron as our base, which powers most of the new apps. If you look at Telegram, WhatsApp, everything uses the same base. With cybersecurity built in, obviously, of building something for 2026, not for 1998, and something that would work anywhere, no matter which computer you're running it on, Mac, Windows, Linux, or even on a web browser, right? So it could run on a tablet or anything. And that's how OpenPLC V4 was born.
Yeah, because so of Japanese listener, even me also think Autonomy is a community like Batman, really. It's very secure, it's secret, and no people know who is in charging it and why he building some open source PLC and then release it free for not just runtime, editor, runtime, and even now you have the Edge solution that allow the people to directly connect all the PLC runtime inside the container in your platform. So if you think, what is this crazy guy? How they can maintain this free? How they maintain this platform or something? Now we have a very clear thinking that why this Batman you do like this and
we all gotta pay the bills, right? So there's this thing I usually tell people, and I realized while I was building Autonomy, is that our purpose is to offer for free what other vendors charge for, and then only charge for things that no one has to offer. So that is basically what we are building. Autonomy now has 3 classes of products. And the core open source and free is basically the OpenPLC IDE and the OpenPLC runtime. That is free and open source and will remain free and open source forever. Our purpose is to keep it like that. But again, as I said, somebody got to pay the bills, right? That's how we survive. But the idea here is to make the bar higher, so offer more things on the whole PLC environment, and so that the basic things are still offered for free, and students, kids, teenagers, they can have access to PLC programming without having to spend any money at all. And still enterprise users are able to also benefit from really, really nice solutions. If we have time, maybe I could demo some of these solutions, and we can talk about that.
Sure. And yeah, sure. You can prepare your solution now, your demo now, and I'll still continue to talk something. Don't worry. Just take your time now. Okay.
Yeah. All right. Yeah, no problem.
Because
if you have any question before we dive into sharing screen stuff, feel free to.
Well, I also touch different types of open source PLC runtime or editor, and that's why I really like OpenPLC is they not just support the text language. They support both of ladder, FBD, ST, even instruction list, and this I never see in other open source PLC. They only tell us, hey, we just support structure tests or something. So sorry about that something. And your ladder and your FBD, even the Japanese, some Japanese engineering thing, is working for not very bad. So it's easy to use than other European brands. That's what the feedback. And also, and I think last year I also used the OpenPLC, but this version 3 to attend a show in Tokyo to show the people, the visitor, that there is open source PLC in here. Then even you can change everything inside. You can repurpose your own version. The response, the action reactions of this guy same as me. Hey, is this guy crazy or not? Why they do that? How they learn the money? And they may have some way. And I also said that maybe there's the other way to other directions. Now I'm saying he is trying to show all the people the other directions to implement the same function in different way, not just use the traditional PLC big brand. You need to spend maybe $300 to buy hardware, and you need to spend more $100 or $200 to buy the license, and then you can start the programming. And even if you, for example, you don't use the brand A, you use the brand B, you need to do the same thing. You need to pay the same build.
Buy more software.
Buy more software, and they still update. And for each update, you need to pay again.
Pay more.
And OpenPLC is trying to showing you that, hey, we have another way to let you to make our work to be open. Because factory automation is always giving the images to people that we if it close work, and when they have their own areas, don't let other people touch that. And OpenPLC is showing the other way. No, we are open. You can use any hardware that you want, even a very low power, low resource Raspberry Pi or USB 2022, or even use a big powerful IPC. You can use the OpenPLC runtime. It's same. So that's what I'm thinking. I'm on that time. What the message I'm trying to explain the visitor that OpenPLC is trying to do in this thing to let the people to have the other way. Don't be the slave of the big vendor anymore. Something like this.
No more vendor lock-in. And I guess the approach is kind of like a change of mindset. I don't think it's fair in plain 2026 to charge for programming environments anymore. It makes no sense. And the shift usually is, if you look at the traditional IDEs, take a look at CodeSys, TIA Portal, even Rockwell, RS Logics, and their other solutions. They all have their legacy look and feel and baggage. Like it's tied to a very traditional old environment, and it's lacking the features and support that we've built in 21st century, right? From the IT world. So things like Git, version control, backup, online backup, cloud storage, things like that. they're not present on these solutions. So what you see is a lot of startup companies growing around these solutions, providing modernization tools for these legacy products. So you see, for example, Copia is a good example, has been growing strongly over the last years. That is essentially providing backups and version control to PLC code, because none of the vendors do that, right? So our approach is like, well, what we can do is offer for free the IDE and the runtime, and then charge for all these other tools that other startups are doing for the legacy vendors. So our solution has everything. It has AI, it has version control, it has everything that you need. And the runtime and the IDE is free. So people that only need to program PLCs, all the basic, is free. People can use that for free, and it's open source. So for a quick demonstration of that, I think it will give a good sense of what
now is the time
OpenPLC is.
Okay, so now it's the time to see the live demo from the CEO, from OpenPLC.
Let's do that.
Okay.
So this is a OpenPLC editor. This is a build, an internal build that I did from one of our development branches, but it should be very similar to what you can download today. And as I said, this is the desktop application. It's a desktop app, and it's free and open source. So anyone can download it from our website, autonomylogic.com, or can build themselves. And they'll go to GitHub and download the source code and build it. Now, you can, with it, go and create a new PLC project just by clicking on this new project button. And I want to create a PLC project. I'll name it Chris Dano and pick a path. I can put it anywhere. Why not downloads? Chris Dano. Create a folder there to place it and open it. Then go to next and pick a language. So I can pick any language for the main program, but I can write function blocks and functions in any other language that I want. So I'll use ladder diagram. I know it's very popular. I guess in Japan there's
it's very
used that. Europe likes to use structured text. So again, you can pick anything you want. And finally, I can create a project. When I create the project, I get to this screen, and the first thing you notice is it's a modern environment, right? It looks and feels modern, different than other traditional IDEs. And as you can see, I'm running this on a Mac, right? So I don't know of any other PLC IDE that runs on Mac.
No Linux, no Mac, just Windows.
Just Windows, exactly. So with the ladder, it's very simple, traditional thing. You create rungs with this plus button here. You delete like that. You can move rungs around like this. And you create your circuit by dropping elements from this sidebar here. So I can go in and get like a contact, drop in there. I can type a name for this contact, and then it prompts me to add a variable. And you see that it's added to the variable table at the top. I can flip the variable table to be in IEC text format.
I like this
I want to. Yeah. So I can copy paste the variables and declarations between programs and POUs. I have a whole library of blocks to get things from. And you can search the library by clicking on this button. So you can just add like a little blinking output so we can test. So I can put like a timer on here. Drop it there. If I click on an element, it tells me what this thing is. If I double click a block, I also can replace it with something else. I can see the description of it. If I hover the mouse over the block, it also tells me what it is. Right? So I have a blink input. I'll negate the blink input so it actually triggers the timer on when the program starts. And then I'll put a coil at the end with the same blink output. You see that there's an autocomplete when I start typing. It suggests me variables that could fit on that element, right? So that's a very simple circuit. If you want to create parallels and things like that, you can just drag things under as you wish, right? You can move elements around. It can move blocks around, right? So it can create any kind of diagram by just dragging and dropping. No need for complicated, button presses.
Okay, I also tried this ladder editor before. It's very great for my even I use other European ladder editor before, and they even you don't know how to put a contact to make parallel.
Parallel.
You need to find a menu to search 5 minutes to do just for these stupid operations.
The basic thing, right?
Yeah.
So we try to make this as obvious as possible. And sometimes it's crazy because we get questions like, how do we draw wires? And it's like, you don't need to draw wires. You just drag elements around and the circuit builds itself.
Yeah.
Right? And users are so, from traditional PLC users are used to this complicated environment where you have to, go to menus and use keyboard shortcuts to do just a parallel branch. Where on OpenPLC, well, it's very obvious. You click on the element, you drag it around, and it shows you placeholders where you can place things. And you let it go, and it draws the diagram for you. Right? So building a simple circuit like this, you can just with no hardware test this by running this on the simulator. Click on the play button. It compiles the project and runs the simulator. So you can see, the diagram in action. You can see, the timers counting the time. You can put variables on your debugger, just clicking on this debug icon here, and you can click on this eye icon to trace the variables on a diagram, right? So you can see, the square wave that the blink generates, and so it's very, very easy and intuitive to get things to work in a few minutes.
I also used the version V3 before, and even in V3 that they don't have a very great of a debug functions. They can not monitor the live value, but after when I used the V4, I feel very surprised that they implement all the things that what factory automation need, and that's why at this podcast that you told me that OpenPLC the start point is first for you to for the lab test the lab for the lab is the lab test the cyber security. So that's why V3 maybe don't have so much features, but in V4 that you fix all the features to match the factory automation field.
Yes, so V4 was rebuilt from scratch with a focus on being enterprise grade, industrial grade software. So not only has all the cybersecurity concepts baked in that I've learned over the years, but also it is built for real actual industrial usage, not for research or toy anymore. But you can still benefit if you, even for prototyping. One great feature of OpenPLC is that it's a generic vendor agnostic IDE. So you can flip between different hardware without having to change your program. So this little blink example here, for example, if I want to, I have an Arduino Mega board connected to my computer. I can flip it to Arduino Mega. And scan for the COM ports here. There's my Arduino Mega board. I can enable Modbus on my Arduino board, but like slave ID 1, and I can map pins on my Arduino Mega board to variables on my program. So I click here on the plus button. There's the pin mapping, and this lists all the pins on my Arduino Mega board. Well, if you've used Arduino board before, you know that pin 13 is the one that has the built-in LED that it can control. So I put pin 13 and select a digital output. It automatically gives me an address. And I can say, this is my Mega LED. Give it a name, right? So I go back to my program, and here on my blinking program, I can flip the location to be on my Mega LED. So this blinked variable is now tied to pin 13, right? And I can then upload this to the Arduino Mega very quickly, and now it's uploading to the Arduino Mega, and it's now blinking. I can see if my camera will work on this. The filter won't. Let me turn off the filter, and you see my messy table. But
it's blinking now.
Yeah, it's blinking there. You see.
All this operate is less than 5 minutes.
Yeah, it's very, very, very quick. And if you see like debugging, I can also debug the Arduino board the same way. You see the RX and TX flashing, it's like going over serial. So it's getting the state of the system and blinking the LED and the debugger as well. So
yeah, that's why I'm very surprised because even in the old classic, let's say it's classic PLC, even you just change the target, sometimes you need to build your project, you need to create your project again. Very, I think it's not possible in 2026.
Yes. We are making this very vendor agnostic. So for example, just to give you another example, I will flip to OpenPLC Runtime V4. So all these targets, they are mainly Arduino compatible targets in different boards, different manufacturers. We do have like PLC vendors here, like P1AM200, Controlino, and some others. But the OpenPLC V4 generic target is for Linux devices. So it's decoupling the I/O from the CPU. So any CPU that runs Linux, a PLC, an industrial PC, a PAC, a programmable automation controller, anything that runs Linux can run OpenPLC V4. And with that, we decouple the I/O from the engine that executes the program. So I have an industrial board here running OpenPLC V4. It's at IP address 188. I can connect to it. I have a very secure username and password, which on my test bench, I don't mind. But even then, for logins, this is interesting. We are not naive with that. The login on the runtime actually uses JWT, it's HTTPS, fully encrypted. So it's following the web standards fully.
No Modbus
to
anymore.
Make sure. No Modbus, yes.
No Unity protocol anymore.
Yeah, to log in and do those things. Obviously, we do support Modbus to connect to other devices, but our entire thing do not depend on Modbus to function, right? So we have our own protocol to log in and to make all changes to the PLC. So you see, this thing is stopped. The PLC is stopped right now, and I can upload a project to it and let it run. But then there's no I/O, so you wouldn't see anything. But then what you can do, obviously I can run the debugger and see the blinking, but it's not blinking anything because it's not doing anything. There's no I/O, but you can add remote devices as I/O. You can do this with Modbus, for example, for Modbus enabled I/Os. You can do this with other protocols, Ethernet IP, EtherCAT. So for example, I have a backoff here on my desk, the EK1818 device, and this is an EtherCAT device.
So new version, I think the version that I test before don't have EtherCAT.
Yes, this is a new version. It's not at this time is not publicly available yet because it's our development branch. But since it's open source, you can go and build your own from the development branch. And the reason why it's not publicly available, we are still closing some loops. It works, but there are some improvements we need to make on the UI, on the user experience. So you'll see that this is a little bit broken on the UI part, but the protocol and the actual running of it is very sturdy already, and it works very well. So I just picked EtherCAT and hit create. So it now has created a new EtherCAT bus. I have to upload this again just so that the bus is active on the EtherCAT side. Then actually I need to select the EtherCAT port. If I'm not mistaken, this is the port from my device.
And I'm very surprised that the OpenPLC editor is very, very light. It means that
Yeah,
I use TI Portal and Rockwell Studio 5000. I need a very powerful PC to run on it.
that's it. Yeah. No, as I said, we're coming from a very easy to use perspective and very lightweight, base without all that legacy stuff with it. So very easy to have this added. Let me just mute here real quick. My daughter is calling for me. 1 second. I'll be back in a minute.
Sure, don't worry. Okay, so now he's talking, take care about her daughter. So let me talk a little bit about what's OpenPLC. So you can download the OpenPLC from the website, but even it's free, and the editor free, runtime free. And then what you do is you just install. It depends on your platform. You can install in Linux, in Windows, in Mac, and in this just very old PC running very well, very light. And then you can program as the language that you like. For some ladder, FBD ST or something that is same as the classic PLC that we are running. And then if you don't have any hardware, you run on PC as Thiago said before, then just like simulations. But even you can use the hardware like a Raspberry Pi, Arduino, the every stuff that you have. You can bring the LED less than 5 minutes. Yes.
All right. So we're back
Yes.
after a short break. So as I said, now we have EtherCAT device here on the bus. So I can select what was the port here? I think Ethernet 0. And I can scan, and indeed I found a EK 1818 on the bus. I can run the scan on any interface, and obviously on the other interface there's no device found. So Ethernet 0 is what actually is running. It's connected to the back-off device, and I just have to select that network interface here for the bus as well. And then I can go to devices, and I have this ESI repository where I can add ESI files. So if I go to backoff EtherCAT XML file, this is what I downloaded from backoff website. Pick AK, is that the device? Yeah, 1818. So I add my XML file for that particular device straight from the manufacturer, and then it detects, this is a backoff 18 class device, so it has all the devices there. And this is kind of classical EtherCAT configuration where you need the configuration file from the manufacturer so that the PLC can know how to talk to that device. So now with support for EtherCAT, basically we can talk to any EtherCAT device out there. Just get the XML file from the manufacturer, and that's it. So now that I found this EK 1818, it found a match, an exact match with our ESI repository. So before I have a match, I cannot add the device, because even though I scan the bus and I can see the device, there's no match with my repository, so I can't know more details about the device. So I can just add this device to my bus, and that's how it was added. There's some configuration on the device if you want to do anything specific in there. And it has these channel mappings with all the inputs and outputs. This particular device has only 4 outputs in it. And I can do like this EtherCAT link. Same thing I did with the pin mapping thing. And go back to my program and make sure this is on my EtherCAT link for my remote device. And now I can, with the same program that I did before, the only thing I had to do was to add, my EtherCAT device. I can upload this program, and let me see if it. So here's the EtherCAT module. Maybe I'll have to turn off the. Let me turn off the filter here. Yeah, how do I do that? I think it's on the camera. Blur background. There we go.
It's bringing now.
Yeah. So you see the little LED flashing is the output flashing. We can turn on the debugger here as well and do the same thing we did with the Arduino and see the LED flashing, right? And it's connected to, this development board. It's from Toradex. It's a Ivy board that is an industrial-based board. So, manufacturers can use this to create their own PLC devices, right? Obviously not put something like this on the factory floor, but it's a base for a PLC device from a manufacturer. And I'm just using this because it kind of is very similar to the architecture of modern PLCs and packs out there, and make sure that OpenPLC runs on it. So you have two network interfaces. One is connected to my router for internet connectivity or anything you need, and the other is connected to the backoff device. And then you can see the blinking output on the backoff, right?
Oh my god!
So it's very easy to make it work.
It's also less than 5 minutes.
Yeah, very easy to make it work.
Okay, so we know that they have the EtherCAT now. Actually, it's not released, but we release maybe this year very soon. I hope. And
no, in a few couple weeks, that's gonna be released. So
I download the latest version, and that is a very great features that I discover, and also Japanese user very would like to know is your function block can create with Python or C++, right?
Yes.
Very surprised that why they do like this, because even you see the classic PLC they don't allow you to do it this way.
Yeah. There's always this fear of using other languages in automation, and I don't see why we are restrained to using only IEC languages, right? And obviously Python being so accessible, it made sense to add it as an option as well. Obviously, you have to be cautious about this because Python in particular is interpreted language. I mean, the language itself is just the language, it's just a syntax, but the most widely available form of this language is using an interpreter, right? So you write Python and you run it on a Python interpreter, which means that your code is being read as it runs, right? It's awesome. You don't have to compile it because it's interpreted, but it has some disadvantages. One of them being the most obvious one is jitter, right? It's not deterministic. You can't never know how long it's going to take from one command, one instruction to the other, and a latency, meaning that the execution time from one instruction will vary next time you run it. This is terrible for automation because you need something very deterministic, very exact. Every cycle is the same thing. But it is great for a lot of features that don't require determinism. I'll give you an example. So you have your PLC and you need to push some data to a dashboard. Traditional way of doing this, well, you can go ahead and add an OPC UA server here. I'll call it anything I need, and then add your variables there. Cool. But what if you need to push that to a database, or you need to publish this on a REST API or something like that? You're limited to the PLC way of doing things. So with Python, you have access to all that power for things that are not necessarily deterministic, right? And that's what we did. We built Python support with that separation in mind. So the runtime stays completely separate, running in real time, deterministically, and the Python blocks run asynchronously to that. So that if even the Python block code fails for whatever reason, it does not affect the PLC runtime running.
Okay.
So there are two separate structures. To give you an example, let's do, counting Python block, Python counts. And we can do this in Python. So again, when you create a function block, you pick the language. You can pick C and C++ or Python besides the other IC languages. And for C and C++, that all the explanation about Python is not effective there. Yeah. The C and C++ are deterministic, so they run coupled to the runtime. So everything you do there will run cyclically with the PLC. But Python, it's asynchronous because of its asynchronous nature, right? It's a non-deterministic nature. So when you create a Python block, it gives you this template where you have this function called block init and block loop. The init is called, when the block is initialized, the first time the block is called, and the block loop is called every time, you cyclically call the block. And that is about every 100 milliseconds or so. And the block loop is when your Python code is executed and when the variables are exchanged with the PLC runtime. So if your Python block fails, the only difference is that there will be no more variable exchange. And the variables are declared here on the top, the same way as you do with programs or anything else, right? So I can add, for example, blink input here, and it's an input class to the block, and I put this as a Boolean. And then I can add like a count value here, which is output to the block, and I'll make it an integer. Just something simple like that. And for true counting, ideally I should do something like last blink value and make it false. For example, I have so many programming languages that sometimes I get messed up with the syntax. And then I can compare, like, if last blink value is different than blink input. Again, I have to just put those variables as global here. That's Python syntax, to have access globally. And last blink value. And you notice you have autocomplete, and if you make a mistake, it will tell you. So I'm just comparing them. If they're different, then what I'll do is if last blink value is true, then I will say count value is count value plus 1. Very simple. And that's it, right? And in the end, I will just do a last blink value is blink input. So this is just to avoid me counting, when the input is true, the block is running many times, it's double counting, right? So if the value has changed, essentially, then I compare the, not the last blink value, but the blink input to true. And if it is, I increase the counter. If not, I'll just move on. So it's just a counter there. And I can also do something like this, print count value, right? I can do a print from Python. So I could be putting this on a database. I could be making an HTTP request. I could do anything I could with Python. I could include other libraries here with an import. It's full Python. There's no limitations to that.
Yeah, because I feel very painful that using PLC language to do the strange text process
operation
right. Is when try to export it as a CSV or something, it's very, very tough. And I just use Python. I can use ChatGPT to help me to generate the code. I don't really by myself.
Yeah, and I'll show you in a minute something really cool related to that. But then you have that added. You added your Python count block. Then it shows up on the library, and then you can just drag that to your ladder. Put blink as your blink input, and then put my count as a variable for the counting value. I add it here, so it shows on my variable list. And that's it. I can upload the project now. And it's going to run.
Yeah, you see, even the Python block in the ladder, it's just like a function block. It's no different to other language. It's very great.
No different.
Yeah.
You don't have to create a bridge or, do anything in particular to have this added. You just code your block in Python, add your variables, and then use it in IC languages like ladder or structured text. You can see from the logs here that, the Python is running here. The block was initialized and it's counting, I can debug and see exactly that. Yeah, I see the output of my Python block. So it's all integrated. You don't have to do anything extra. No plugin installation.
Is not here anymore. Nothing painful thing.
Yeah. So this is OpenPLC. This is what we offer for free. Now the cool part is what is the extra, right?
Okay. So before you say in free, that actually I see your GitHub. Okay, I know that you have two type of member, right?
Yeah. There is we do have. I think there's something we've added in is like a support sponsor on GitHub that people can subscribe, and this is just a way to say thanks. It's like you can subscribe and donate some money. Same thing goes on Patreon. Some users will just go there and add some donations to the project, which is really nice. And we do get some donations, and we really appreciate the users that are doing this. But for the time, I mean, they do get some exclusive channels for support, but the vendors are actually migrating from just the sponsoring with actually doing some projects with us. So this is how we are expanding. We do get support from users with donations, but we also have project with some added features that we're doing with other vendors as well, and those are the extra things.
So that's what I also say very interesting in the GitHub. They have different types of member that can allow the people to join. And
that is
okay. And now we know that you're OpenPLC editor. We know your OpenPLC runtime. So finally, could you show us a little bit about your age automate the age part, because it's also very interesting part. I think even other Siemens or some other big game player in the factory automation, they also try to build this type of platform, but they have a very great charge on that. And at least I know that it's free, right, to manage your device.
Yeah.
So could you let me explain us what is the background and why you will build this type of features.
So let me show you this. We do have right now 3 classes of products on Autonomy. The first one being, the free and open source core, the OpenPLC editor, and runtime. The other one is what we call Autonomy Node. So it's a version of both the editor and runtime running inside a PLC. So it means that the PLC is essentially self-programmable. You don't have to install any software on any computer to program the PLC. All you need is a browser. We are developing Autonomy Node. It's not publicly available yet. We are developing it in conjunction with 2 big PLC manufacturers, one in Europe and one in the United States.
Okay.
And this solution will be available on their own products. And shortly after, it's available for purchase within the PLC that they will release. We'll also release Autonomy Node for the general public, so users can install it on any other target, Raspberry Pi or anything. So basically this product is very interesting because since our IDE is so much web-based and lightweight, we can put it inside a PLC, and all you need to program the PLC is a browser, a web browser. So I have to demonstrate the concept, I have a prototype of it running on a PLC. Let me get this shared screen.
Yes.
So here.
It's his showtime now again.
Yeah. Well, all I have here is a web browser. So I'm in Safari. So I'll just type the IP address of my PLC, and it loads, like a web server. It has a web page here. And this is the device. This is the PLC. So I can just log in. And when I log in, I have this interface where I can go in and add projects to the PLC device. I can import a project from my computer, and I can export project that is in the device on my computer, right? So I can go and create new project, for example, like I'll create a quiz demo as well. I can pick a folder where I want this thing to be. I'll program in whatever language, could be structured text, just to be different, and I create a project. So it has created the project here inside, the root of my device, and I can download this project to my computer and work it on the desktop IDE. I can save and import it back, from the desktop IDE, or I can just click on it and program it from the browser. So essentially, it's like Node-RED, but for PLC languages.
And you see
Right.
and you see the screen that the operation I think is actually same. Because I tried the Edge platform. Actually, the operation is 100% same. You don't have any additional click or something. What you do in the OpenPLC editor is what you can do in the OpenPLC Edge. The Edge
Yeah.
platform same.
Yeah.
I think it's
Yeah.
fantastic. Really, in my view.
Yeah. And again, this is not the Edge platform. That's the third product that I was going to talk about. This is the Autonomy node. It is a different target than Edge. So just to explain a little bit about what Edge is, and I will show that a little bit as well. The Edge platform is an online cloud platform where you can program your PLCs from anywhere. So you install an agent on your PLC device, and it talks to our cloud securely over an MTLS connection. And then you can manage those PLCs, start, stop, program them, debug them from anywhere in the world with just a browser. Same IDE running on a browser. The node is for, customers, and especially vendors that are interested in still having that air-gapped, no network, no cloud connectivity solution. It's different than the on-premises Edge because this thing is not actually running on a industry server or anything like that. It's actually running inside the PLC.
Okay.
So you have a single PLC device running Linux. Now you install Autonomy Node, so it's coming straight from the vendors with Node pre-installed. And again, Node is not free. That is the agreement we're doing with vendors. So there are some features of it that are licensed by the vendors, and some others that could be licensed by end users, like advanced features, AI, protocol support, and things like that. And but the main advantage of it is that the device itself is self-programmable. So you don't need to install, when you're going on the factory floor and you have a PLC device that is running whatever version of the runtime, and then you have to install like TIA V17 because it's an older device. So it has all that mess with your computer because you have a newer version of IDE. You have to downgrade it to program the PLC. That's a mess.
Yeah.
So now you don't have to worry about anything. You open your browser, you point to the IP address of the PLC, you see that portal, and then you program it. So same thing. You can write your code here, you can upload the code there, and that's it.
Yeah,
No difference.
It's very great point that even me, I also always go to the site that I need to write a memo that show this site I'm using, for example, Cotis V3.5 21. This website this site is SP20, SP4 something. I need to write down all this. I need to install all this software in my computer. Even one software will spend me 3 or 4 gigs.
Yeah, that's exactly the difference. Like we can have it all in the device itself. And following the same trend, there is also the Autonomy Edge. So I'm going to our staging environment, which has the latest features we're developing. And Autonomy Edge allows you to get into a cloud collaborative PLC programming environment where it has like a feed of users creating projects that you can click and visualize and copy over to your own platform. But it also has the ability to create organizations where you have a private company where all the projects are shared within your own organization. You have users access control. And on the edge, the difference between Edge and Node is that Edge runs on the cloud, right? It runs on the internet. And so the way it talks to your devices is basically you add an orchestrator. You click on Manage Orchestrator, and then you click on Adding a new orchestrator. And this allows you to essentially add, a PLC device. Give it a name. There's this curl command that I can copy here to paste on the terminal, the Linux terminal of your PLC or device or any Linux device. And that will install our agent. And once the agent is installed, you get like a card with your device like that. So I have already a device added, and this thing is running, on a Teradex IV board. And inside my agent, I can create multiple PLC devices. So for example, I can go here and create yet another PLC device. I will call it Chris VPLC. And pick, the latest pre-release version and configure my network port. That's the one I want to use. Click Next and create a device. Takes about a few seconds to spin up a new virtual PLC device on my real physical PLC device. So I can have multiple PLC devices running inside the same PLC, right?
And I'll try this. And it's also a great thing that even now you see you create a PLC project in the Edge platform, then you're supposed to say, hey, maybe I only can create the program in the web browser. No, you can also use the open editor to connect to the runtime that you created in the Edge. It works. It's great.
So this Chris PLC that I just created, it is, since the device is on my network, this new virtual PLC device got this IP address 1.106. So I can go to OpenPLC editor and disconnect from this thing and connect to Chris virtual PLC device that I just created, 106, hit connect. And because it's the first time, it's a brand new virtual PLC device, I can, program it, give it whatever username and password I want. I created the first time a user, and there you go. I can program from the desktop app, but I also can program the same device from the cloud, from the edge. So for example, I'll just open whatever project I have here. It's opening the irrigation controller project. And then I go to my devices orchestrator. I can again run the simulator here as well, or I can connect to my Chris virtual PLC that is on my stack. So I hit connect. Again, I created a username on the desktop version, but I use exactly the same to connect because it's the same device. And I log in, and now I'm over the browser. I'm connected to the same PLC.
It's very great.
Right.
Very fantastic. Just like
And I
magic
can-
in my rate.
Yeah, so there are so many things that can be done with this. It simplifies the flow significantly, allows you to, program devices from anywhere in the world in seconds. You can manage your whole infrastructure here, all the PLC devices that you need. And for this particular PLC, I guess it's just the image that I have running there that is I picked the dev build, so it's not running there. There's something that's got stuck. Oh, there we go. It's now it ran for one scan cycle.
Okay.
Right? I can't play it again. But anyway, you have the capability of doing so much in a web environment, including like what I said, version control. So for example, for this project, I can go and see the history of changes. So I can click on one of the commits and view all the changes that were made to that particular commit, right? I can see even on graphical languages, I see that, what changed on the function block diagram is that this new block was added, right? And a new variable was created on the top. So
If these features, even in some Japanese brand, you need to pay the money for these features.
that's what I told you, yeah.
Some manufacturers, they don't have these features.
They don't, and that's exactly what I told you. We offer for free what everyone is charging for, and we offer for a fee for paid what no one else has.
Yeah.
Right.
So now
this is a feature that is really interesting. And again, going back to what I mentioned with Copia does something similar for vendor PLCs that none of them provide something like this. We are building this baked into our own solution. So you have version control, you have AI. So you go to, for example, one complicated ladder logic diagram, and you click on this AI button, and you say, what does this irrigation controller POU do? And ask a question about it, and it will analyze and give you an answer back based on the context. This is what this POU is doing. And it can also help you write code for anything you need. So take, for example, manual override, whatever that is. You can say, write me a condition, fix the if conditions to have vol as false by default. And then you ask something, and then it gives back, the results that you can simply insert into your code, right? And that's it, right?
Also, you'll be charged if I need to do it in the traditional PLC. They'll charge you every month, I think.
Yeah. And those are the things that we're building with our products. This is Autonomy Edge. And then again, as I mentioned, Autonomy Node. And for free, everyone has access to the core Autonomy OpenPLC editor and Autonomy runtime.
Okay, so we spent more than 1.5 hours to talk about the OpenPLC and also this crazy guy how to hack the PLC. And now the OpenPLC they have free parts that allow the user to use it by free. They have the runtime, they have the editor, they have the edge to allow the user to feel free to play with that, to integrate it in the machine line. And then they have a custom library to play. It's called Node. It's a web browser based, and you no need to install all the versions of an editor in your one PC. You can just have a browser, Chrome or Firefox, everything. So for me, it's a very great solutions or a new solution that is to open a new door for us. Hey, this is a door for you to not to go for one vendor. And this is very great for me. And so, okay, finally, could I ask you about the roadmap? What is the plan of the development in this year of the OpenPLC?
Yes, so the roadmap is right now, Edge is our platform that we're focusing the most on and is available for free while it is in beta. So it's coming out of beta over the next few months. The purpose was to, have the general public access to it and provide feedback and, see if there are any challenges to using it. And then we will release the pricing tiers for all the features that we have, like what I showed today with the AI and with version control and all of the nice features from Edge. And those pricing tiers will probably come around, Q2, perhaps around June, July this year.
Ooh.
And that will be obviously a free tier where users will be able to continue to experience and enjoy the platform for free. As I said, our main purpose is to disseminate the awareness for automation, and we want as many people as possible to have access to automation, programming, and languages and all of that. So Edge will have different tiers. The free version will still be there. Users will be able to upgrade to the greatest tiers with a 14-day trial, so they can test all the features for a few days. And there is also Autonomy Node, that is being jointly developed with some other vendors. And the roadmap after that is essentially to expand our use cases on industry, to have more real use cases, on different areas of the industry, food and beverage, machine vision, and also integrate more AI capabilities, adding 21st century skills to PLCs.
Not 1998, not the project.
Yeah.
1998.
Yeah.
Okay, so I think that today
right.
the old listener will be lucky because all the features that he is showing is still not released properly for EtherCAT, AI, version control. So don't miss to watch our video, and it's really great video, great podcast today. So finally, could you have anything that would like to say with our Japanese listener?
Yeah, well, first of all, thank you very much for the opportunity to share some of my story. And since I was a kid, I was always fascinated with the Eastern countries, Japan and Asia. I played video games when I was a kid, and I had the Mega Drive, the Sega Mega Drive.
Really?
So, and there's a lot of, I remember playing some of the games that had some of the Japanese culture baked in, and I was always curious to learn some more. So definitely, it is something that I want to learn more and probably visit Japan at some time. I do have some messages from Japanese users that have used OpenPLC before, V3 before, and I'm very proud to have received those messages as well. So I guess in the end, all I have to say is appreciate everyone listening, and hope that OpenPLC can bring some opportunity in Japan and worldwide to expand industrial automation, not only to be more accessible, cheaper, but also to bring more modernization. Japan is definitely a very developed country. A lot of robots, and the factory floor is definitely known for that. So hopefully, with OpenPLC and this accessible technology, open source, Japan can help improve it even better.
Okay.
With the technology.
Okay, thank you. Okay, so fine. Let me also just talk a message to Thiago-san. So first of all, thanks for joining this podcast. So it's really my pleasure, and actually, in this moment, I also can believe that a PLC that is open source and free can let you do all these features. And I think this is, as I say again, it's very great challenge. A very great chance to let all the people now, factory automation to try to choose their next solution for their future, for the line in the future. What kind of architecture, what kind of PLC that they use. Actually, also, be honest, maybe OpenPLC is not it's not their own choice in the world, but what is showing is also a choice that allow the user to know that the work is open. Okay, so I think this is my message that I'm feeling today. Okay.
Awesome. Thank you so much, Chris, and thank you for the time, and thank you for opportunity to share all of that. And if you guys need anything, feel free to always reach out. We're always in the forum at Autonomy Logic Forum, sharing questions and needing guidance or advice on anything PLC related.
Okay, thank you. So I think we spent more than 1 hour and 40 minutes in this podcast. So I don't want to spend so much time for him and his daughter. So please have a good day. So thanks for every listener. So see you next time. Okay.
Thank you, Chris.
Bye-bye.
See you.
Bye.
Bye.